In the next problem, or the next type of problems, we are going to discuss exponential growth and decay, something you learned freshman year, but you definitely may need a little refresher with. So exponential growth always looks like this. As long as it hasn't been moved, it hasn't been shifted left, right, up, or down, it comes in from the left and it rises as it goes to the right. This is growth. Decay comes from the right and rises to the left. So it's like they're just reflected across the y-axis. In both cases, unless we've shifted the function, they will never cross the x-axis. It is a horizontal asymptote. It's a boundary. You'll get closer and closer and closer, but it will never actually touch it. So if somebody were to ask you, or on a test, if it said state the asymptote, you would have to state this line. And if there's an equation for this line. Every point along this line has a y value of 0. Okay, so again, this is exponential growth, this is exponential decay. And we'll do some word problems later that look at this. A lot of times they use examples of the growth of cells, like cancer cells or bacteria cells that grow rapidly. And they use things like the depreciation or the value of a car over time. It goes down. Okay, so here we go. Here is our first problem. This is the problem. By the way, does this look like it's growth or decay? Okay, so here is the general equation when you're looking at a graph and you're going to write an equation. It looks like this. That's the general equation every single time. A represents the first number, which is known as the y-intercept, and B represents the rate. With exponential growth, this B value is always greater than 1. If this B is greater than 1, we know it's going to look like this. If the B is less than 1 but greater than 0, if that's like the rate, if it's less than 1 and greater than 0, we know it's going to look like this. It's going to be an example of decay. Okay, we already know this is growth, but we're going to be able to show that in a second. So how do we do this? I personally like to write out a table. And so I know that x being 0 goes with 3, and x being 1 goes with 6. And so we start with what's the y-intercept? It is the number 3. And now I need to figure out what is the rate. And to find the rate, you take the second number divided by the first number. So 6 divided by 3 is 2. That's your answer. Done. That models this equation. By looking at this, we can also say, oh yeah, it's growth because this rate is greater than 1. Again, 3 is the y-intercept. It's considered to be your initial number. That's always the y-intercept. And then this rate is the second number divided by the first number. Okay, next picture. Draw yourself a simple graph, please. Give me 1 second. Okay, so this is going to be off the charts, and that's okay. But let's pretend that I tell you that negative 3, it's going to be way up here. Negative 3 goes with 500, and negative 2 goes with 100. So I can see it's going down, so it's going to look like this. So I can predict that's going to be exponential decay. But how do I come up with the equation of it? The equation that models this information. Well, first make yourself a table. And I can see that we're starting with the negative. So negative 3, negative 2, negative 1, and 0. 0 is what I need to know. Negative 3 goes with 500. Negative 2 goes with 100. Okay, so how do I get to this number? Can everybody see how we're going down? Okay, please take 100 and divide it by 500. 100 divided by 500. And you end up with an answer of So what that tells me is if I move to the left, I can multiply by 0.2. Let's try again. Please, we need to check it out. Take 500 times 0.2. Do you end up with 100? Yes? Take 100 times 0.2 and you end up with? Take 20 times 0.2 and you end up with? Okay, why do I stop? Because what I actually need to find out is, what's this initial value? What's the y-intercept? So y equals 4. My rate is 0.2 as I move to the right. Problem is done. How can you justify that this is decay? Because 0.2 is between 0 and 1 as well. Okay, go find your numbered partner, please. Take your paper, pencil, or pen and calculator with you. Yeah.
How come you use the last numbers, the 0 and the 4?
Because 0 is the number you always have to go after, the y-intercept. Good question. Okay. Yeah. Okay. This time I tell you negative 4 corresponds to 48. And negative 3 corresponds to 24. It appears to be, again, exponential decay. As it goes to the right, it's going down. Let's make ourselves a table. Go all the way back to 0. So how am I going from 48 to 24? We'll take 24 and divide it by 48. You end up with a decimal of 0.5. So as I move to the right, I'm going to multiply by 0.5. Let's check. Please take 48 times 0.5. Do you end up with 24? Take it times 0.5. What do you end up with? Times 0.5? Times 0.5. This is what I care about. This is your y-intercept. So here's your answer. Y equals 3. The rate is 0.5 raised to the x. Okay, we're going to stop for a second and go back to the last 3 problems that we've done, and we're going to add another aspect to this. If somebody asked you these 3 questions, I need you to be able to answer these correctly. What is, for this problem, what is the specific? Identify the y-intercept as an ordered pair. Turn to your partner, what would it be? 0, 3. Okay, what is the equation of the asymptote? Y equals 0. Okay, now on paper, please write down the end behavior. Go. Timing, Moises, I'm calling you shortly. Write down the end behavior. Okay, so here we go. As I go to the left, as I go to the far left, this is getting closer and closer and closer to this line, but is it ever going to touch or cross it? But what's the value it's getting closer to? It's getting closer to a y value of 0. As I move to the far right, it's going in which direction? Up. Okay, let's go to this one. Okay, in this particular problem, we have a y-intercept of 0, 4. We have a horizontal asymptote of y equals 0. And let's practice once again writing down what is the end behavior. Whether you verbalize it with your partner or write it down, as long as you understand it's more important to me right now. Okay, go ahead with your current partner. What is the end behavior? Okay, as I go to the far left, which way is it going? Up. And as I go to the far right, what is it getting closer and closer to? 0. Okay, thumbs up or thumbs down right now. Okay, let's have you try the next one without my help, just working strictly with the partner. Give me 1 second. Okay, oh, made a mistake. All right, your points are going to be 3 goes with 13.5. And 4 goes with 20.25. So we can see this looks like exponential growth. Now, I need an equation that models that information, that data. Ready with your partner, begin. You had one full time?
No, just right now. It wasn't.
Okay, yeah, go for it. I'm going to give you 30 more seconds before I go over this with you. Okay, I think the most confusing part for students is how do I come up with these other numbers? What do I do? And do I take 13.5 divided by 20.25 or the opposite? Well, I can see that from one number to the next as I move to the right. Do you see how it's going up? Yes? Okay, do me a favor and take 20.25 times 13.5. If I said times, I'm sorry, I wrote down division, I meant divide. And what do you end up with? I came up with 1.5. So what does that mean? It means as I go to the right, I'm going to multiply times 1.5. Try it. Take 13.5 times 1.5. Do you get this answer? Take 13.5 times 1.5. Do you have this answer? So if you multiply going to the right, to go to the left, you have to do the opposite operation, which is divide. So please take 13.5 divided by 1.5, and you end up with an answer of, okay, divide by 1.5. Give me the answer. Divide by 1.5. It's 4, correct? Okay, there's your answer. Y equals 4, and 1.5 is our rate raised to the x. Bless you. Okay, the next thing we are going to do is we're going to talk, bless you, we're going to talk about translations in graphs. So you're welcome to write this down or simply just watch. Okay, 3 separate problems. All right, now just watch. Okay, do you notice that these are all on the same level if I did this nicely, and these are up above as exponents? Okay, just so I want to make sure that's clear. Turn to your partner. Which one shows the original function being translated to the left 2? To your partner. Which one says, I'm going to take this original function, I'm going to shift it left 2? Which function says I'm going to shift the original function down 2? Which one says I'm going to shift up 2 units? And lastly, which one says to the right 2 units? Okay, so when you see the number in back, that is going to represent a vertical shift, just like we've learned. So if it's plus, you're going up, and if it's minus, you're going down. Then if we have a number that's up above in the exponent position, if we're moving to the right, if you're moving to the right, it's going to be the opposite sign. It's going to be a negative. If you're moving to the left, it's opposite. It's going to be a plus number. Okay? Make sure you and your partner understand that. Okay, let's